Welcome back to the stream, folks. Let's try and get this going. Looks like we are live on YouTube on the Scanlime-in-Progress channel and on Twitch, twitch.tv/scanlime. Tuco is over here enjoying the temperature gradient, I think. It's a little chilly, but he seems to really want the outdoor access right now. Anyway, I was going to try to make this a mostly chill stream, just like hanging out and working on camera, on chat together. I've got this Rust sandbox project I'm continuing on, which is in some like kind of difficult debugging territory right now. It's one of those programs that has some hurdles between you and just like running a regular debugging program. Like usually you can't run strace or GDB on a program that's already got a ptrace process attached to it, so that's part of the problem. And then it's also just in this kind of weird locked down system call firewalled kind of sandbox arena. Anyway, the high-level goal here is to make some tools that help folks have kind of a more effective solution for hosting video in a decentralizable way. So kind of some new stuff to help PeerTube and PeerTube alternatives work better. But the particular piece I'm working on right now is sort of a really lightweight container engine that's intended to be how I do video transcodes from inside of an existing like video server daemon. I wonder if I can find a better place to put the camera to get Tuco on screen here. This is going to be tricky to dodge with my body. Oh no. Oh, Tuco's moving anyway. He's got this little warm spot. He's been oscillating between that and the area near the outdoors. Will he object if I close the coldness? It's cold and kind of noisy. Oh, now he wants the food. Anyway, it's nice to have the cat cam back. Oh, welcome back to the chat, folks. I'm always trying to pay attention to both the YouTube and the Twitch chat. It's not that I've forgotten, it's just that sometimes I'm unreliable. Anyway. Let's rev up the old text editor. Actually, I've been enjoying Emacs these days, so it's more of an operating system than a text editor, but it seems to work all right. Is Tuco leaving already? Well then. We'll be back, Tuco. Alright, I have a couple of projects in here other than the container itself, which is bandsocks. I've actually been referencing the source code for Linux quite a bit, just when I need to know the specifics of how something works in the Linux kernel that I'm trying to emulate. It's always nice to look in there. Muscle is a particular C standard library that one of the programs I'm trying to run right now uses. And so I've been needing to refer to its source code to try to figure out some of the problems I'm running into right now. But let's start with something that works maybe just to test everything out. So the basic idea here is that it's a library for Rust that makes it about as easy to set up like very low privilege containers as it would be to set up just a standard subprocess. So in this case, we're naming a particular instance of BusyBox, which is just a little, like it's a tiny collection of command line tools designed mostly for embedded systems. I'm just using it here because it's a really simple thing to start trying to run inside of one of these containers. So I'm referencing a specific version of that, downloading it from the default registry if it's not already in the cache, and just starting it up. Oh, do I not have vterm mapped? Anyway, so this one actually works, the one that just runs BusyBox help. Oops. Yeah, so much has to happen behind the scenes for that to actually work, but it does work. So far, the best debugging I've got really is just additional logging. So I use one of the kind of popular logging facade libraries in Rust called log, and there's a standard, or a kind of common module that folks use to set up filters and sort of pipe that to standard error called nvlogger that takes this Rust log. So anytime you use this library with that nvlogger, you can have this Rust log environment variable kind of for free. The most detailed setting is trace. I don't know if I'm going to keep it this way, but right now if you run this with trace, it will actually trace all of the instructions that are happening. Gosh, I wonder if this terminal in Emacs is going to have trouble with that much output. I might open up a regular terminal too. Oh, I need to fix this menu. I think this terminal is a little faster, even though vterm is pretty nice for an Emacs terminal. It's not quite a native terminal experience. So if I go one level less, just debug, then we get significantly less going on here. It does give us information about all of the messages that go back and forth between these things that you're seeing called the IPC server and the sand. The sand is so named because it's the thing that goes inside the sandbox. It's like the base that you put down before you put the application in there. What it's actually doing is it's like a runtime environment that knows how to convert all of the sort of more privileged operations that I'm not allowing in the sandbox, like, for example, opening a file, into less privileged operations that are allowed in the sandbox, like, say, sending and receiving packets over a Unix domain socket. So the IPC server is actually a server that it's connected. There's an instance of one IPC server and one sand process per container, but you can spawn multiple containers. They're fairly lightweight objects. It's just that one of those containers represents, a unique process ID namespace, a unique copy on write instance of the whole file system. It's intended to be like a separate little, a full-on sort of copy on write little isolation container thing that you can create cheaply. And one of these actually gives you a lightweight task in your original program that implements this IPC server. So if you had multiple containers here, all of the IPC servers could be running in the same like async Rust thread pool that your main application is running in. And they're just acting as the I/O glue between the inside of the sandbox and the outside of the sandbox. So it's mostly doing things like logging right now and opening files. It does this open process thing at the beginning so that the sand process can get access to like metadata about the memory maps and file handles in the individual process and verify the process's ownership. So you get logging about these messages going back and forth between the sand and the IPC server. It's actually opening standard in and standard out using this. This is another thing, I don't know if I'm going to keep it this way, but for now, the way it actually gets standard I/O inside the container is by opening these special paths /proc/1/fd/0 through 2, which is completely a special case. Like I don't have an actual proc emulation implemented yet, but I'll need one eventually, and so I'll need to decide whether this is still a special case or whether I do standard I/O some other way. But yeah, I mean, it's communicating back and forth to get access to files. And then the other major thing that's emulated right now by this is actually the process of executing a new process. So like loading an ELF binary off of disk, that has to be emulated because the file system is all emulated. So when it comes time to do an exec, the sand process actually does that pretty much on its own. It'll use this IPC channel to ask for the actual file. So let's actually find that. That's actually pretty like way up here. So okay, actually no. So the first several things that run here are they're not even the process that we're trying to run yet. This is from the loader, which is it's basically the same binary that sand is part of, but run in a different mode where it pretty much just loads command line arguments and environment variables into the stack and calls exec, and that's pretty much it. But it does also set up its standard I/O. So each of these emulated system calls here has an instruction pointer at the end, so we can actually see where these are coming from. And this is just from the addresses. Like I know that my loader doesn't produce executable addresses like this yet, so I know this is the original process before it's called exec. So it's setting up some of its stuff. It is actually using the dynamic linker. This is one of those things that's kind of unnecessary, but I don't know if there's a good way to disable it in Rust's build system right now. It's intended to be a fully static process, but it's also compiled using the same toolchain as the rest of the application, so I can't, like the usual way to compile a fully static Rust binary is to switch toolchains, so I currently am not doing that. I'm just not using the standard library, and I'm using system calls for everything, but technically the dynamic linker is still actually running. I just don't rely on it for anything. It's kind of inconvenient. Okay, so we're opening standard I/O. So that's standard error right there. These file opens themselves are kind of complicated because each of these starts out as an open system call that the loader makes. So that shows up first right here. The sand task gets one of these emulated system calls. It records the system call parameters, the return value. Actually, this is on the way out of the system call, so this would not be the first log we got from it. That would be, I guess, yeah, you don't actually get the full story in this less verbose logging mode. So I think the first thing we're seeing here is just this IPC traffic, but this is also asynchronous, so sometimes the stuff happening inside the sand process and the stuff happening outside is not perfectly synced up in the logs. We're doing some stuff that doesn't actually matter yet, like changing the working directory is not even implemented. But then finally we're doing this file open of BusyBox. So this is going to be inside the emulated exec. So it'd be cool if I had some logging for when the emulated exec was actually starting, but I think it's going to be the first system call right after this emulated sys80, which I think this is the change working dir. And it's marked as a warning here just because it's unimplemented. I have some of these escalated just because they're stubs, and I wanted to keep an eye on them. But I think between these two log lines, we're actually starting to emulate the exec system call. And so then the sand process traps that, and inside the emulation, it starts out by opening the actual program we're trying to exec, so bin busybox, getting a real file handle for it. So the file handle itself goes over this interprocess communication channel. There's a special serializer that takes the file handles and actually sends them in a separate buffer so that we can send like access rights to those kernel objects rather than just sending them as a number. So all of these syscalls that say remote instead of emulated are actually inside the exec system calls emulation. We're generating a bunch of these remote system calls where the ptrace process, the sand process here, is kind of remote controlling this temporarily stopped thread and asking it to run a bunch of system calls. I mean, this is mostly done by manipulating the CPU registers via ptrace. So on the way into this tracer, the reason we stopped is because there's a setcomp filter that's stopping on particular system calls. So when we stop, we'll already be in this position of being like about to run a system call. And in that state where a system call is about to run, Linux lets the tracer modify the registers on that stopped process. And then if you want, you can restart it and let it run that system call. So there are some cases where you can do that. You couldn't just use that to implement like a file open firewall, because you can modify the CPU registers, but you're kind of on a different level of detail from the string that the kernel is actually reading the path out of. You could modify the pointer, but you couldn't safely pass the kernel a new string without having to pass it through untrusted memory. So, there's some limitations to what you can do by just modifying the parameters for system calls. But because the whole way that the emulation in SAND is based on, not like conferring privileges through the ptrace emulation, but using the ptrace emulation to rewrite disallowed operations into allowed operations. It means that if we are taking a quick trip into user space, or putting some memory or putting some values in user space somewhere where they're not safe from a manipulation by a malicious app, if we're not actually using that to confer privileges, it's not actually a security hole. So that's what I'm trying to do with this like remote system call approach, where I'm trying to emulate exec in terms of things like open and mmap, and if the process interferes with my open that I'm actually running from user space with user space permissions, then it could have just run the open directly. It doesn't actually gain anything, and it's just broken its exec. So the problem would show up if it was possible for an application to get my emulated kernel into some kind of improper state by interfering with these intermediate operations and causing it to fail in some kind of unexpected way. So you do have to be guarded and program defensively here, but it seems like it's possible to use this to make a nice, relatively simple and relatively secure kind of additional layer of sandbox that you can use to run things like media codecs and whatever you want to have very low privilege, but run it inside of a Docker image that isn't itself privileged. So the exec implementation is actually pretty complicated, and I don't remember all these system call numbers off the top of my head, but it's actually going to do a bunch of things. Most of this is going to be mapping memory, but it's got to unmap memory also, and some of the operations that it's doing require a little bit of temporary storage. So it's got, for example, like a scratchpad page of memory that it could allocate in order to supply buffers for receive message so that it can receive a file handle. So it'll end up kind of layering these different abstractions. So maybe some operations just require it to stop the task and replace the system call, but some operations require it to stop the task, allocate some temporary memory, and then replace the system call. I generally am trying not to do anything dynamically sized in the sand process. So it's processing just these little like fixed size IPC messages, but things like path names and argument lists and environment variables are actually just transferred directly from like one address space to another, or from a file handle to the target address space. And I don't ever have to deal with those inside the sand process directly. Oh yeah, Trevor on Twitch chat says that this reminds them of gvisor. Yeah, I was a little bit inspired by gvisor. I mean, this is a little bit like a very lightweight version of gvisor implemented in Rust. gvisor intends to have a much thicker separation layer between the inside of the sandbox and the outside of the sandbox, because I think they're also running stuff that is fundamentally a lot less trusted. So it's just like really focused on ratcheting the security boundaries up to 11, whereas I'm trying to do something that is pretty secure but is also really focused on I/O performance. So whereas gvisor emulates all the system calls, I want to be able to share certain kinds of kernel objects between the inside and the outside of the sandbox, like especially file handles. So read and write system calls should be a straight pass-through, and my hope is that even though some of the operations I'm doing, like this exec, require layers and layers of emulation, once a program is actually loaded and running, it'll mostly just be doing I/O via read and write, and it'll be using relatively fast inter-process communication mechanisms like futexes, and that stuff will all run with very little intervention. And my hope is that this will have pretty low performance overhead for running FFmpeg, which is what I'm really trying to go for here. I just want to run FFmpeg from inside Rust without a hassle, so I'm writing a giant emulator. This is already so complicated. Last time I checked, it was actually like 10,000 lines of code, which is certainly not the biggest project I've made just like on a random whim, but it's starting to feel substantial at least. I feel somewhat accomplished that like exit codes and standard error and standard out are kind of working properly at least. So anyway, a lot of stuff doesn't work though. So if I go over to Hello World, which is another very simple example, this just crashes like nothing else. So yeah, Hello World is also pretty simple, but I'm just trying to run echo. And I think the difference here is that cat doesn't allocate memory, but echo does allocate memory, because I'm pretty sure we're crashing inside of malloc. But let's grab a fresh trace of this on this computer, because I was working on it on a different workstation before. Oh man, which clipboard am I putting this in? I don't usually run Emacs in its GUI mode these days. I guess we're putting it in that clipboard also. Cool. Anyway, so I've got these test cases, I've got some little example programs, but I've also got something that's designed to be more of like a general purpose command line interface. So let's build that. Oh, actually, and I don't want to run the version of this. I made this mistake on the last stream too, because I didn't have this totally set up. I want to actually run the version of this with symbols, which is not the one in the test case here, because it's not checked in. It's just one that I built here locally. I was also realizing that another mistake I made on the last stream, like while I was trying to demo this stuff at the very end after talking about a bunch of only semi-related stuff, I was getting myself confused over all these break system calls that were showing up as returning 0, which they should not do. And I was under the impression that I'd implemented break, the memory allocation system call, pretty correctly, pretty much. But it was just returning 0. Apparently it does that because my loader was calling break. So somewhere in the standard library code that I'm not actually using intentionally, somebody is trying to call break even though I'm not actually intending to allocate any memory. And it's failing, but nobody cares. So I think that's what I was seeing in the logs. But if I scroll down past where my new program is actually execing, after exec, my emulated kernel has the right pointers for the process's data segment, whereas before it didn't. And then break succeeds, and it seems to be doing the right thing, but I think the crash we're going to see involves crashing inside of malloc on what seems to be a pointer in the free list of memory chunks that points into memory that has not been relocated properly into the binary's final address. And so that's about as far as I've gotten. I don't really know where that address is coming from. I could guess, but I haven't really investigated that. Anyway, I had made an image for this. GTS is wondering if I'm still using Do Emacs. Yeah, I'm pretty into it. I've got that installed on all my workstations now, so I've been using Do Emacs on Windows and Linux and Chrome OS lately. Yeah, I think this might be an interesting, like an interesting sort of weird little adjunct process or project to gvisor, like something that tries to explore a distinct space in the, or a distinct point in the space of possible like emulators or container runtimes. Because yeah, it's specifically designed to have this kind of niche, low privilege use case where I don't want to be using any of these fancy kernel features like user namespaces, like bind mounts. Like I don't even want to be using the real kernel file system. So it tries to use this very small set of Linux functionality. I'm even not using writable proc mem right now because one of the machines I tried to test this on, even though I thought Linux had support writing to proc mem files since forever, one of the machines I tested on had that disabled, and so I figured, well, we don't really need this. We could just use the ptrace syscalls to write to memory. So that's what I'm doing. But it is kind of nice that works, partly because there is so little data that I actually have to move back and forth between address spaces. Like for example, to get the arguments in the environment into the right process and into the right address space, those things could be arbitrarily large. I don't want to have to be poking those 32 bits or 64 bits at a time or whatever through ptrace, but I end up using a lot of like memfd temporary files to read stuff into a buffer and then write it elsewhere and that kind of thing, and that seems to work pretty well. On an operating system, is this Mac or Linux? This is actually Linux running on a Mac Mini, but that doesn't especially matter. It was just this is the Mac that I have been doing demos on since forever. I just kind of got fed up with running Mac OS on it, and I didn't actually need Mac OS for anything these days. This machine has different terminal copy and paste than I have set up everywhere else, though. I should fix that. I think that's the right binary. So this is a control. This should work. I don't expect this to crash. Oh, it's going to be extremely verbose, though. Let's not. Yeah, okay. When I'm not being extremely verbose, that should also be quite fast. Like, I wonder how much of this delay is coming from cargo and how much of it's coming from my software, actually. Let's just try running this directly. If I'm going to try to care about performance, though, I should at least do a release build. It's weird how much faster the release build is. Like, I mean, I shouldn't be surprised because I think the debug build is not optimized at all. But I think, I don't know. I should measure it, but it feels like the decompressor is like an order of magnitude faster on the release build. That shouldn't really matter now though, because I mean I'm not decompressing the image every time I run it. Should have saved my command buffer from the other window. Do the emoji work in this terminal? They do. I've been debugging this a lot on my Windows machine, which runs Emacs all right, but emoji does not work in its terminal. That's funny. I've gotten false positives on that unsafe paste with the weirdest things. Like I try to paste, I mean, I'm pretty sure it's told me that for this exact string before. It's weird. Anyway, so it gives me a signal 11 if I run the default binary in there, which I think is Alpine's shell, which probably crashes for numerous reasons, like it's probably dynamically linked. There's the actual BusyBox. So that runs. Cat was also working. Echo was not. Cool. That's the address I'm used to. Okay, so far this is nothing new. This is just making sure my setup is consistent and reproducing the same crash from before. So yeah, part of me is really annoyed at how verbose the trace mode is, and I want to make some somewhat finer grained settings, but I think I'm just going to dump this all to file and we can sort through the mess. There's a suggestion from chat that I might be able to use build.rs to change some of the Rust flags to get rid of dynamic linking without swapping out the toolchain. I'd be curious what you mean by the flags, because yeah, I mean it is a totally separate build. Like I mean I can show you my build.rs. It's it just invokes cargo, and I actually had to kind of mask the cargo.toml in the nested project by renaming it, because otherwise cargo publish assumed that was a separate crate and excluded it from the build. So yeah, it's a bit of a hack right now. I'm also using nightly Rust for the sand build because it needs some features that aren't in stable Rust yet. Mostly around the interface for like panic and main for no standard. But yeah, it tries to be pretty self-contained because it's like swapping out a bunch of the infrastructure underneath itself while it runs. So I wanted to have pretty careful control over the system calls that it invokes. All right, how fast is this when I'm not going through cargo and a debug build? Yeah, that's nice and fast. Less than 100 milliseconds to invoke the command. And so, I mean, this involves reading the file system metadata and building inodes and RAM and all that. But I mean, it also helps that BusyBox is pretty small and simple. It might be a more impressive demo to like load Ubuntu here. Ah, that is actually much faster than it used to be because I wrote a, I spent some time writing a parallel downloader and parallel decompressor for this. Let's see what it's like. I don't know if actually know if the cache was totally empty though. How am I downloading Ubuntu that fast? Gosh. Yeah, so the decompressor is vastly faster and on a release build. That was 28 megabytes, just going like nothing. That's great. Maybe Alpine. Actually, if I remember right, Rust container is not actually that small. I wonder what it would be like. Yeah, right. It's got like 150 megabyte layers in there. I should really have a progress indicator for this, but like since this is mostly designed to be embedded inside of like headless servers, the progress indicator wasn't really an API priority. So if I rerun this, it should be much faster than 21 seconds. Yeah, 240 milliseconds to unpack the file system and run the binary and crash. This one's hitting a null pointer. That one probably is just calling into like a relocation that hasn't been processed because I'm not running the dynamic library interpreter at all. This is the entire stack that it's printing out, just with gaps omitted. And so you can see at the very top of the stack, these are the arguments and environment variables, and the top 16 bytes are actually random. There's this, I didn't know about this until I started implementing a loader, but there's an elf feature that passes a random value in as a parameter, which I guess libraries can use to seed their random number generator or whatever. I don't know actually what it's used for in practice. Got this weird vsyscall segment that we're totally ignoring right now. I don't know why Ubuntu insists on enabling that emulation. Oh yeah, so I guess there's some elaboration on the Rust flags from Twitch chat. No standard lib and static. Is this for Rust C directly or with cargo? Interesting. Yeah, I'll have to take a look at that. I'm still using cargo right now because I do have a bunch of dependencies I wanted to process, but I'm not using the standard library. Yeah, if there are any Rust build system experts here who want to give me some tips on how to make this suck less, I'm all ears. Because yeah, right now I'm running this nested cargo build. Using a bunch of dependencies here, but they're all pretty small. And I also always want like the best link time optimization and just like optimization in general that can be offered right now, because I would like to keep this binary small on disk and small in the cache, since its job is to just not take up space and to get out of the way quickly. I think last time I checked it was about 1/4 megabyte, which isn't terrible. All right, did I finish that log file? Yay, instructions. So many instructions. All right. And let's get the disassembly up to match this. So I compiled this busybox with symbols, but I did not compile its C library myself. which might have been a useful step, but I mean I've still got probably enough symbols, and like that doesn't seem to be really super annoying right now. So it's crashing right there. Sometimes it's ambiguous whether the address you're dealing with is the instruction that caused the fault or the instruction after the one that caused the fault. In this case, I think it is actually this instruction. I think it's this RAX write to this address, CD or CBFDF, which is not part of any of our maps and looks suspiciously like a non-relocated version of something that would be part of our program's text segment. So yeah, this is the real text segment, the executable read-only. This is a perfectly valid instruction pointer. This seems like it would be something nearby, but and it looks like this is an address that we're getting out of the linked list that keeps track of free memory chunks of a particular size. So, and I don't have exact line number information here, but we got the lay of the land here with this madvise here, and there's also something that looks like a mutex here. You've got a bus level lock up here, and then you've got some kind of waker right there. So somebody's doing some kind of mutex operation. We're indexing into an array of items that are this long, it looks like. So there's like a couple of hints right off the bat. And then these, like this whole section is pretty conspicuous because of these page masks and the madvise. So like that plus the source code, and we should have a pretty easy time identifying that. So let me pull that up really quick. Oh, actually, I had that already over here. So this is actually an old malloc. I don't know why we have old malloc instead of a newer malloc, but that's what we're dealing with apparently. Oops. So it's not that, it's the double underscore bin chunk. So there's the madvise. There's a lock. So I think we're inside of this non-double underscored bin chunk, which is actually like legit manipulating the next and previous pointers. So it would be really useful right now to have a core dump. So one way to approach this is to get core dumps working. But I think it might be worth just trying to understand this enough to figure out where that pointer could have come from, and then look for those addresses in the existing instruction pointer dump I've got, just to see which code paths we're even on here. Linking the C runtime statically is actually not what I want with my Rust thing. I actually just don't want the C runtime. I just want an ELF binary that makes Linux system calls. That's all it is. I mean, it seems like the first place to check is probably where we're doing the break here. So expand heap. So maybe it'd be useful to know if we're just getting here at all. Oh, do you not take symbols there? And so this actually does call break. If the break fails, it tries to mmap. But I mean, I don't think we're on that code path anymore. So E5809. There we are. And there's the emulated mmap inside the break. And there's the end of the... Or no, sorry, this is the emulated... This is the initial emulated break that gets an argument of 0. So this is where the C library is just trying to probe to see where the program break currently is. I think that's inside expand heap. Yes. So yeah, this is a static variable, so this is actually allocated outside of the program, or outside of the function scope, and it acts like a global as far as lifetime goes. And here, the first time through, we're just going to end up calling break with 0 to initialize it. And this is a little weird. I haven't worked out this for sure, but it looks like it might be trying to round up to the next page boundary. It's like a weird way of writing that. Page size -1 is a mask of the bits within a page offset. I think using a negation like that is going to give you the number of bytes that you would have to add to reach the next page aligned. So I think this is acting like a ceiling function, rounding it up to the next page, which makes sense. Like you'd want to start allocating maybe at a page boundary after the program break. Like you can't go before that program break because you have other segments there. But you can move that up arbitrarily, so if you move it up by an amount that causes it to land on a page boundary, then you'll be able to make page-aligned allocations out of that. And then we're just adding this n value to break. Note that n is not page-aligned, so that happens a little bit further down. So, and the way these are written, this starts running, but I'm not emitting a log message for the start. I'm only logging when it finishes. So this remote happens inside of this emulated operation. So we're doing an emulated break at this address, which actually causes me to allocate 1 page of memory. This would turn into an M remap or an mmap or an M unmap, depending on where the break is actually moving. So that's fine so far. All of this is as expected. Do we have any... Are we doing that more than once, I wonder? Just once. So that's fine. That matches the break behavior we're seeing. So what other ways are there of putting memory in the heap? Okay, there's Malik's entry point. It would actually be maybe useful to know like how many times Malik is getting called. Like, are we crashing in the very first Malik? Or are we freeing anything? One malloc call. We can even see where that's coming from. 9EAO. Ah, xmalloc. And 9F301, which is echo main. Presumably it needs a buffer to hold the parameters or something. Always seemed a little weird though that echo needed memory allocation, but cat didn't. I'm actually kind of curious now. Do I have the busybox code on here too? Oh, what version of busybox was this? This image is actually kind of big too, because it was like just my whole build environment, not minimized in any sort of way. Oh yeah, we got a couple of folks asking about this binary ninja thing. Yeah, it's basically like it's sort of like IDA. It's like a disassembler. And they've got kind of a free / commercial model at this point. There's a commercial program you can buy and run locally. And then they also made this web version that's basically, like for public use. Like, I don't know if you can have like privacy in the web version, but if you just need a quick way to disassemble something that is fine to publish, then this is really convenient. Less logging, please. Mm. 1.32.0. Fancy echo. There's our xmalloc. Yeah, so it needs a buffer to concatenate all the arguments together. And we allocate to one regardless of how many arguments there are, it looks like. Oh, and it's gotta do the escapes. Interesting. Pretty simple. Weird. That's kind of interesting. This must not be enabled, but there's a version of echo that doesn't allocate. Alright, well, where else could that memory pointer come from? I think there were some other places where we could end up with pointers being inserted into the list. Probably worth making sure that no one's calling free, but I doubt it, given that we've only got one malloc. Free alloc. Is that the right log file? Yeah. I was looking forward to having a really good cat cam for you all today, but Tuco disappeared right before I wanted to start this stream. Okay, no free. Yeah, and then there's this malloc donate thing. Let's check it too, because that could easily cause this kind of problem if we're actually using this. That looks like it wasn't even linked in, so no. Oh, what about this bin chunk? I think bin chunk is always used when we're sticking a chunk into a bin. So let's see if that was the first case where we're calling bin chunk. Just that one. Interesting. Let's try to get a more detailed idea of exactly which pointer is a problem here. So the crash is CD1PA. So R12 is an address in the data segment, like in the heap. So this looks like that page that we just recently allocated. Oh. Yeah, this was the last break that we got, and it was at A5000. Yeah, so this is in a recent heap allocation, and then AX is the one that looks completely wrong. AX just recently came out of... I think I checked... I think 18 was next, but let's double check that. Oh, previous. So these are all 8 bytes. This would be 0, 8, 10, 18. So this is, can we comment here? Hmm. Fine. There's a question about the memory, or the window manager. Is this XFCE? Yeah, I think it is XFCE. Look at that. It is something that will mostly get out of the way and supports alt drag. I haven't customized it besides that though. It does feel weird to browse ancient C code. Yeah. If you want to feel weird about ancient C code, then C standard library is a great place to do it. Gosh. This coffee mug is completely indistinguishable now. This used to be a Portal mug, or an Aperture Science mug. Oh, you can very slightly see it on the side, but yeah. What is bin to chunk? Thought I was going to be staring at Rust code on this stream, but apparently staring at C code is also in the cards. I'm just getting slightly confused by the order of these. I was feeling like this might be part of that bin chunk function, but here's unlock, Maybe the compiler reordered some of this, but I wouldn't expect the log to be able to move. So maybe this is calculating something for this conditional? Or maybe some early calculations for this? But that multiplied by OX18 looked a lot like some of the indexing I would expect in bin chunk there. Oh, mostly I just want to know if there's some kind of initialization stage that happens before the first malloc at this point, because that's probably where I'm messing this up. I mean, it looks like this just initializes on the first call to malloc, though. Let's see if either unbin or bin are getting called early on. I already checked this one, CCF1E. Just the one. I don't actually know that core dumps don't work right now. Like, I have not done anything yet to specifically disable core dumps. It might just be that I'm catching all the signals that would have caused them. Oh yeah, it would be interesting to have different ways of putting comments in these disassemblies rather than just like source code comments. This whole thing could be like pretty non-linear. Was that reflowing as I was zooming out? Okay, like how does this get actually initialized? I mean, maybe part of the problem is that something is supposed to get zeroed and isn't, although like all the memory is coming from anonymous mmaps, which the kernel zeros on access. So like we've got this global data structure. It'd be cool to have a snapshot of this to see what's actually in it. I was thinking like what would be a nice way to make this slightly easier to debug without adding a bunch of extra infrastructure. There's clearly a bunch of stuff that I could do. Like I could try to get actually GDB working. I could try getting core dumps working. The simplest thing might just be to add some kind of like attachment delay so that instead of crashing immediately on a seg fault, it lets me attach something to the memory device so that I can dump segments out myself. But like at that point I might as well almost just like have a regular core dumper. And see, like if I was recompiling this, I would try to turn this on so I could call it, but right now I have not been compiling the C library. I'm just using the one that was already in some Alpine image that the BusyBox build usually uses. It would be interesting to try failing break and see what it does when I get on this other code path. It's like normally they're using break to continuously resize one memory mapping, but there's this alternate strategy which doesn't even use mmap fixed, but uses just a generic mmap that the kernel can place anywhere. And it kind of assumes that there's going to be some memory fragmentation as a result, but tries to make the mmaps relatively large. So that's kind of weird. Like, it would also be nice to just like bulk resolve all of these to symbols. Very weird. Part of me just wants to modify this logging to dump even more registers out so that I can try to look for the pointers that show up. Actually, I've had a lot of luck with that approach before, like writing emulators, just doing just like brute force register logging, and then just being able to very quickly notice the first occurrence of some particular problem value that I'm looking for. Like, pretty much the only reason I haven't already done that is that I was kind of lazy about adding stuff to the logging, because that's like part of the protocol now. So I'd have to include the register set structure in the inter-process communication protocol. But that seems inevitable. I don't know if that's really avoidable. I'm just putting it off. Yeah. I've been trying to keep the extremely architecture-specific stuff out of the protocol, but that's mostly just for aesthetic reasons at this point. I also feel like there should be another log level beyond trace for single step. And the only reason I haven't already done that is that I'm trying to be compatible with the log levels in that Rust logging facade. I wonder if there's a way to add new log levels to it. By the way, if you want to follow along with the Rust side of this, I did finally put a recent version of this on crates. So if you search for bandsocks there, this is roughly the same version I'm working on still. This is pretty recent at this point. And there's a repo and some documentation. Some things are documented. Most of the interesting stuff is in this container builder. Also, like, a lot of the really interesting functionality is going to be behind this, the mount method. There's just this trait right now, mount, which is something that you can mount into the file system, which I intend to be pretty open-ended. Like, it could be some static data that you want to patch in there. It could be some kind of socket. Right now, the only thing that supports that is this particular kind of shared socket. The intention is that this is for stuff where there's actually only a single socket that multiple parties are using, which is the case for standard I/O. But I'm also going to have a version of this where every time you open it in the virtual file system, it could be a different socket. So it's more like a socket listener. All right, can I add new log levels? I don't think I can add new log levels. I think the single step should be separate from the logging flags anyway. Just not quite sure where to put that at the moment. So like this signal log message could have a full register set in it, and this init message could have a single step flag in addition to the max log level. That seems useful. also be useful for that to be like a temporary state you can put the task into. I feel like the way I've been conceptualizing that max log level is that it's more like a default. So that's in this init message here. This is only sent once per container. So the idea is you have a single like argument initialization event, but maybe this is just a default max log level and a default single step value, and those could be overridden later, but right now there's no way to actually change them after initialization. Which is probably fine for now. It seems like this could just be a long option. That's not a good name. Instruction trace is better. Probably goes without saying that that's very slow. Could just be another function you call on the container builder. The log level is not specified directly. That's actually handled through the log module. So you would set it for the bandsock sand subsystem in the log module rather than setting it on the container here. Gosh, it almost seems like if we're gonna do that, that should take some kind of parameter that indicates like where the trace goes. And it shouldn't just go to the log file, but it should go to some kind of special purpose receiver, maybe? I'm not sure I care about the instruction trace being a useful feature outside of debugging, but I don't know. How bad would it be to be able to override the log level there too? I feel like it would be weird to specify the log level just for the sandbox runtime in the API, because that kind of exposes the boundary between like what's in the sand runtime and what's outside of that, which is a little bit arbitrary. That's weird. MIDI controller I used to run the audio here just like reset itself. Haunted. Let's try that for now. I'm not really happy with that though. Oops. Yeah, so the container struct itself is entirely concerned with a container that's already running. So it actually does not have much data in it. It's mostly just got this join handle, which refers to a task that's already taken ownership over all the parameters. But the builder has a lot of parameter info. So I think this will just be a bool. Oh. Tracer. isn't this tracer settings part of the protocol? Does kind of seem like that setting should move into the protocol. Maybe let's do that. One thing that's cool about this protocol is that it doesn't have to be, like, it doesn't really need any like heavy compatibility guarantees. The particular version of the binary on either side can always be matched up, so like we're always compiling the runtime with reference to a very specific sand binary and sand protocol. That seems fine. And like, while I'm here, maybe I want to change the log types to include registers. So right now, stuff like registers are in this other file, ABI. Like, I've got to decide whether I want like the same binary format to be required in the IPC protocol and in like Linux's ptrace interface, which is what this is based on. It would also be convenient if I could split up this protocol file a bit, because it's already pretty big. It's just part of the way my weird build system works right now is there's a build step that just includes this file into another build. So right now it's kind of difficult to split this up. So it's actually just one file that includes the serializer, the deserializer, and the data structures. I guess I could make a protocol ABI submodule. I mean, this already sort of includes parts of the ABI, right? Like, we're using usize, which is technically part of the ABI. Yeah, let's just put another pub mod in here. Just gonna make a mess. Kind of seems like syscall info should be in there too. Right, like I'm gonna want logging for system calls also, and right now that's a bit ad hoc as well. I've got this log syscall thing, which is, it really wants to be syscall info. It's just a stripped down version of that for the purposes of protocol.rs. So maybe I delete log syscall and move both syscall info and user regs into protocol ABI. I can move this nicer debug formatter over to syscall info though. Makes the ABI file a little bit smaller. So everything in here also has to be serialized, deserialize. Oops. Oh, this should not be copy. Oh, and I was going to implement debug myself on this. Oh, and on user regs. Oh, I always want a thing that will re-indent the buffer even if it is not syntactically correct yet. I've not quite set that up. Especially with modules that are too long, like this one. Hmm. It's tempting to make those parameters to from regs just so they don't have to include them in the protocol doc or in the protocol file. And like that also seems somewhat more correct. Trampoline protocol and syscall. That's nicer-ish. It's also possible I should put that whole function in ABI. Neither of those fields actually matter in this case. Like, it's kind of annoying to be using a structure at all that has fields I don't actually care about, because either I'm going to be setting them to like the correct value using some effort that's never actually verified, or I'm just going to be leaving them at the wrong value. The syscall info thing is, it's used by the ptrace ABI as one way of passing around information about a system call, but I don't actually use it because it's a little bit more efficient to just get the data you need from the registers instead of asking for the syscall info separately. Who's using this structure? I mean, I'm logging it right here. Like, I mostly just want a structure that includes the args and the syscall number, but like sometimes I care about the return value and sometimes I care about the instruction pointer. Maybe sometimes I care about the other registers. So like it's basically just turned into a structure for viewing a set of registers as a system call invocation. Yeah, maybe I just change it even more. So I don't think it needs to still match the ptrace version of that structure anymore. I feel like that would be a little more convenient as U size instead of U64, but I'm a little torn. I mean, this is like the most architecture-specific piece of it. default. I don't know if we need default. I think I decided a while ago that the generic form of these syscall arguments makes a little more sense as signed rather than unsigned. But it could go either way. Oh wait, these are the regs. Just spin the wheel and change all the data types. Okay, these should all be usize. Cool. That's a little simpler. This is where we would have a string table if we had a string table for the syscalls. Okay, let's try to make this compile. I do kind of adore how Rust format lets me just make whatever kind of syntactical mess I want as long as it's valid in some way, and then it'll clean it up for me. It's kind of nice. I'm used to having to spend a bit more time manually formatting my code. Oh, that's right. Yeah. That seems better. Yeah, I agree with that. There's a comment that sometimes it'd be nice if Rust format respected the original spacing a bit more. Yeah, I think it's kind of deterministic where like you run it and it gives you basically the same output, but I don't know. It seems like some original white spaces do get preserved, but most of them don't. I should look into that more. This is like the whole reason I wanted this, was for these log messages. That's better. Slightly mind-blowing that this is a relatively new way of getting the register set in ptrace. The old school way was to ask for each register individually with a separate system call. So I'm glad we don't have to do that anymore. I'm out of coffee again. I'm actually going to refill my coffee and take a quick restroom break and see if I can locate Tuco. I'll be right back, possibly with Cat. I've got two go. He's just gonna take my seat. I trust him to finish debugging this. Oh, maybe we can share this spot somehow. He's acting like he wants me to open that door again. Yeah, stream's still going. I'm still working on this Rust project. I'm just taking a cat break. I guess it can be a cat and coffee break since I did refresh that too. Tuco, do you want me to open that? It's kind of cold, but he seems to like it. Oh. Investigating the trash, Tuco. Oh, that's better. Brr. Oh, it's like he leaves when it's cold, but I have to stay here. You coming back over here? Yeah. Now he wants me to open the door again. Oh, Took. Yeah. Tuco. Yeah? Man, it's like old times with the Tuco tripod. Can I squeak by, Tuco? Will he mind if I close the door again? Oh, did someone have a successful spaceflight experience? That's cool. Gotta put those things up in space and make all the big bucks, right? Now Tuco's behind me. I kind of like being this tiny human in the frame with a giant cat. Tuco seems to like that kind of food better when I don't take away the packaging. It's a meal and a toy. Let's see if I can get this on screen along with everything else. Is that a cast I can make? Tuco, you want to look outside again? Tuco. Got that like, lumpiest possible look here with the microphone transmitter in my pocket. Hey, Tuco. Tuco's making these angles challenging. Cleaning mode. He does need a bit of hunting with his food, it seems like it. Gosh, what a good cat. Huh? Makes me a little nervous when he's sitting on that box. If the lid closes, it probably cuts the fiber optic cable that's running in there. I should finish actually running that to the garage properly. Do they sell nylon bolt-shaped cat food? That would be funny. Tuco is such a picky biscuit when it comes to food. His current favorite thing is like this awkwardly small plastic package of little meat chunks with gravy. And now that he's discovered this, he hardly wants anything else. You just want to look out there? Neighbor cat was there earlier. I don't see him out there right now. It's kind of cold. I hope he's got a warm spot to be. Can I write code while the cat is here? Or is that hopeless? I feel like I'm just getting in the way of him. This is super relaxing. I really like the Tuco close-ups I can get with this lens. Man, I've gotten multiple questions about how ergonomic this keyboard setup is that's like floating in the air. And yeah, it's not intended for like long periods of use. They basically only use it for like streaming stuff and for like computering while I'm doing electronics. I have a much more ergonomic setup for like more computering kind of things. I've been using this weird split keyboard, so my hands are like kind of hovering pretty far apart when I'm typing a lot of the time, which seems to be helping with some of the like random like finger discomfort that I would get when I spent a lot of time typing. Gosh. I can't get over what a cute boy this is. Giant cat. programming stream interrupted by an adorable cat. Something out there is really interesting based on his breathing. I think there are some birds. It's interesting that the neighbor cat who visits pretty often nowadays was coexisting peacefully with some birds. I was worried that the birds would be in danger, but they didn't really seem to mind each other. Tuco gets extremely excited about birds, though. Maybe I can raise the camera significantly. Get some upness on this. How in the way is that? There should be a lot less casting if I have like U size in both the register set and V pointer. I'm still obscuring the cat with my terrible typing here. Can we share the screen again, maybe? I'm antsy to do more programming, but the cat is really, really cute. Oh, 2 goes over there now. Oh, that's convenient. Oh, the actual signal number is not part of the register set. I do need that. It'd be cool if I could ditch this special case and actually include enough debugging information in like a general way that I didn't just have to dump it all out to standard out or standard error. Hey, that's the separate instruction trace option I was wanting. Tuco. He makes such a mess with those. Do I have to cast each of those separately? Probably do. Did you go back over here for more? I think he wants the door open again. Oh yeah, he's... Tuco. Oh, now you're leaving again? You sure you don't want that? Oh yeah, he's still interested. Clearly, I should have a gimbal for this. That's all you wanted? Oh, Tuco. Okay. Is that kind of compiling now? Seems like it. So the sand compiled, but now the outer layer needs a little bit of work because we need to pass the right parameters. So init just takes that tracer settings message now. Nobody outside sand parses the log messages yet, but so yeah, like right now they just exist to go into a debug formatter after they cross the socket. Oh, Tuco, are you back again? Oh, honey. Whoops. It's a very good cat. I think Tuco's looking out the window. Where is he going? It's like I need a couple of different cat cams now. You want the door again, honey? Oh, kitty. Alright, init, args, and tracer settings. Tuco, you're back over here again. Tuco definitely wants me to open the door again. Okay, boy. What a bossy little nugget. sassy little potato. Oh gosh. Right, even the arguments are kind of complicated. We initialize the command line arguments in the environment by passing a file descriptor that you can read some data from, starting with this header. Oh, it seems like tracer settings should be set up one level higher than this. Okay, and now whoever calls IPC server gets to set that up, which I think is container. Mm-hmm. Okay, now tracer settings can come from something like up here. Oh. Actually, it seems like this should come from the builder. Like, this whole tracer settings structure should come all the way from the builder. Okay. This exec is really unwieldy, but it's purely an internal API that is used to glue the container builder to the container proper. So the idea is that it could change, like this could change pretty much any time, but the actual builder API is quite stable. Or at least it will be. I mean, I'm adding something to it now. I think I can just store that in self. Could definitely add a parameter to change the sand log level if I want now. That would be really easy to do. Oh. Oh. These are going to be used from sand, but not from the IPC server side, so I should mark them as allow dead code. Does that need allow dead code? Maybe. Like if nobody uses the formatter, will I get a warning? I think so. Can I just put this entirely on this module? Can I repr C an entire module? That seems doubtful. Oh. It wasn't dead yet. I was expecting it to be dead, but still running tests. Let's kill it though. It's probably downloading ffmpeg just there. I think the ffmpeg container is kind of large. Like small, I mean, they stripped it down as much as they could, but I think it's still like 80 megs. Maybe I'll get another coffee refill. I'll be right back. Huh. It's like Tuco was leaving right as I was coming back. Ah, it's cold in here. Oh, are you coming back, honey? Were you using that? Oh, Tuco. Hey, fuzzboy. Tuco is a very unpredictable co-host for this show. My human co-host the other day was much more predictable. Ah, Tuco, your hands are so pretty. Whoa. Are you trying to get down or just trying to get comfortable? Still working on that food, I guess. Oh, the birds outside are super cute. Yeah, I'm glad Tuco appreciates them from a safe distance, though. I wouldn't want him hurting them. I usually put the food in the bowl so that it doesn't scoot around, but sometimes he takes it out. Whoa, the test's passed. That's a good sign. Let's see if my new command line flag works. Tuco, are you just making a meat mess everywhere? He probably wants more. Alright, there's the command line options. Now we have --itrace in addition to -l. I feel like it's pretty counterintuitive, though, that right now, the way this is set up, itrace will only work if the log level is also set to trace. I feel like it might be less confusing if itrace always did something, so maybe the logs it generates should just be at the maximum enabled level, rather than always at trace. Let's try that. I mean, we can verify, but I'm pretty sure that right now the behavior is not quite what I want. Because I think if I do something like -l debug, busybox muscle echo hi. So I get some debug messages. That's what I expect. But then if I add --itrace, it'll run slower, but I won't actually get the extra trace messages. I mean, not even noticeably, so. But then if I repeat that at a higher debug level, then it should show the difference. So now I'm getting more logs, including trace. --itrace. Now, oh, now I'm getting all the registers. That's great. Extreme logging output. We're also getting 2 copies of each message because there's the actual log output and then there's the debug message showing the IPC traffic that carries the log message. We're not even out of the loader yet. These are still loader instruction pointers. So yeah, this is probably not something you want to output to the console at all. Yeah, it still seems like we want that logging to show up even if this level is set differently. So like, for example, if you don't say -l at all, the default is info. And it would actually be kind of handy for, in that case, itrace logs to show up under info, so that you just get fewer extraneous logs, but you still get to see the itrace that you asked for. Let's try that. Those are currently not specifically for iTrace at all, though. I mean, that's probably fine. It is a sig trap. I don't know about that. Right. So panics will actually turn into an exception outside the sand process. It'll log the, it'll turn the standard error output and the return code from the panic into like a result error. Not an exception in Rust, but you know, like an error code that makes sense. Do I have real signal codes here? Why are these U32s? Signals are very 8-bit. Ooh, what did I do? I think I got my editor into a mode I don't understand. Panic. Let's just restart that. Oh, 2 goes right over there again. I get too absorbed in the programming and I'd forget to cat. Maybe I'm just messing that up. Okay, clearly I've forgotten how to do a block replace. Fine. Okay, who's expecting a U32? Why are these U size? I probably should have used cint for some of these. It could seem kind of unnatural because I'm not using libc, but I could just define that myself. Gosh, could I color key that matte 2 goes on? I don't know if that's better or worse. You can see a little bit more of the window behind him, but the flicker is a little annoying. I didn't intend to buy a green mat. I think that was originally like a yoga mat, but then I was using it as like a temporary place to sleep, and now it's just there because Tuco likes it. I've used it as a bed much more than I've used it as a yoga mat. Alright, IPC SIG.io. I think I actually do want that to be a U32. This syscall macro, I think, automatically includes a bunch of casts. Event. Ooh, can I save space in my event buffer by using smaller signals? Or do those need to be bigger? Where did Tuco go? I think he's over outside. Oh, what are we doing here? Oh, right, stop task. I've got this thing, I don't know if this is like a normal Rust thing. It seems pretty normal, but I've got this technique I'm using in several places where I have this object which is normally not wrapped with a mutable reference, but then sometimes you take an additional mutable reference to it in order to signify that it's in like a special state. So like here I've got a task object, but then I've also got a stopped task, which among other things includes a new mutable reference to that task. So he kind of keeps you from taking that reference while somebody else is already using a mutable reference to the same task object. Oh yeah. See you later, Took. Hey. Tuco is always so very meowing. The extremely meowingest kitty. Alright, where is this event? Oh, Tuco, you're back again. Now he wants the door open. Yeah, I know you want the door open, Tuco. Just a sec. Is that all? Oh, this cat. You're back again. Clearly you just don't want to be in one spot. I understand. Doesn't want to be picked up either. That's cool. Alright. Events. Event signal. Gosh, status is explicitly not just an event code. I think it's supposed to be 32 bits. Yeah, these are all 32 bits. That event is something that I think the task or the tracer object defines. Event. Oh, process event. This is the queue that communicates between the kind of main like IPC socket handling code and the individual lightweight tasks that represent each process inside the sandbox. So I think I can turn that first sig into a U8, but the others need to stay U32. So it doesn't actually save any space. Thanks, padding. Let's just see where the errors are there. I think mostly in task. It's better. Oh, Tuco, don't do that. No. Tuco likes scratching at like posters and stuff that are on the wall. And so I don't even have much hung up right now, but I've got this one calendar that he keeps trying to scratch at. Honey, do you just want more food? You just want more food, huh? Such kitty. Oh, is this... Why is this U32? If that's U32, I really should represent its entire range in that event struct. This is all stuff that comes right out of ptrace, so I kind of do want to represent all the values that ptrace can give me, which apparently includes 32-bit signal numbers here. Why? Fine. I don't like adding more casts here, but those are actually different types. This is basically all the code that has to deal with low-level events between the lightweight tasks. Oh, that's a pattern. Ugh. Is it even legal to use constant values like that in a pattern? Hmm. I feel like I should just do if and compare the entire structure here. Ugh. This is not the prettiest. Oh, do I have more types of events? Why is this even an enum? All right. It's also used for messages going in the same direction. I just never expect to see a message when I'm in that particular weight, so none of them show up in the match. That doesn't seem terrible. I really like the type system in Rust. Yay. Now we are tracing. Gosh, you can watch the loop counter. This is going to be a lot slower because we're sending the entire register set over the IPC channel, so there's just a lot more bandwidth being copied from place to place right now. But look at all that debug data. And it's at info log level now, so that's all we're seeing. If we set log level to trace, then we'd see some other stuff, and that would show up lower. Yeah. Cool. Tuka was just there, and he left again. Yay, log. Such log, very file. Okay. And it ends with the crash we wanted, CD1VA. Ooh. That's interesting. I don't see the same faulting address we had before. We had some value that was much closer to the top end of this empty range than that. I mean, not that close. It was something in the like CD 1000 range. So it was close to where the text segment is, but without the relocation. This is just like 8. This is just like somebody followed a null pointer and then added an offset to it. Also, I think this is the sig trap we got before actually executing the panicked instruction. And then it panicked, and we got a sig 11 from the same instruction pointer. It looks like the rest of these registers are the same too. CD1VA. Same place we were before. So we got an 8 out of this. R12 was what now? 100F20030. So same location relative to this segment. All the addresses are randomized, but yeah, the offset's the same. So I don't know why we're seeing a different value here, but it might have just not been a stable result to begin with. Like, there shouldn't really be any truly uninitialized memory at this point, though. Like, we should be setting things up inside of zeroed pages, so that's a little weird. Let's just see if that's stable if I run it again. I'm gonna take another restroom break, but I'll be right back. Still 8. That's weird. Does it change when I single step versus when I don't, I wonder? Oh, you know what? I was setting this up a little lazily, and I'm not actually running the right version of BusyBox here. So that's almost certainly why it's different, is that I'm actually running a different binary. The addresses are likely very similar, though, because this is probably the same binary of the libc. This is the same, probably, muscle binary. But I don't know for sure, because this is just like a random tag off of Docker Hub at this point. So I actually want my image from the local star. Where did I put that? It's this one. I should just save this somewhere. Headset's starting to dig into my skull at this point in the stream. Oh, hey, Tuco. Tuco, you're back. That's an interesting question. Lucas asks how hard it would be to make a joystick out of 2 drawing tablets. Why would you need 2 drawing tablets? And like, what kind of joystick? I'm kind of confused about what you're going for, but it does seem like you could use a tablet as some kind of two-dimensional position sensor. Most tablets are not really optimized for measuring like tilt, so some of them measure tilt magnetically, but that's not usually super accurate. You'd probably be better off using an accelerometer if you wanted to actually measure tilt. But if you want to measure like XY position along a plane, tablets are great for that. You could definitely repurpose a tablet for something like that, as long as the like distance isn't too great, like more than an inch or so. Okay, we've got our instruction trace. Let's see if it crashes in the correct spot here. Yes, okay, now it crashes at CBFDF. That is interesting that the address was so completely different, though. Maybe this is a bit more of a coincidence, and this address is mostly just some garbage which lies outside the map segments, and maybe it has nothing to do with relocation. But yeah, the rest of this looks fine so far. So let's see if we can find that CBFDF value elsewhere. That's interesting. That's just like right up there too, and one of the other, presumably this is just one of the other linked list pointers. That's AX on CD1A4. So, yeah, this linked list pointer apparently is the same value. Interesting. Is this just a buffer overflow somewhere? How am I even doing that? No CBFDFs. Okay, what about the pointer holding the linked list node here? Oh, what is going on here? What is R13 plus RAX? Oh, RAX here is the computed offset. I don't know what var54 is either. Yutuko, what do you want? Oh. That's cool. I mean, it looks like 11D460 is that array of bins in Old Malloc. This is pretty weird. Is this even like a valid offset? I mean, we could look a little closer at that, but so far I don't see what's wrong with this. A2 go. Smaller room than last time I had a cat cam, huh? Oh, now he's actually leaving again. It kind of looks like my face is like being covered up by the window right here because the edge is just right. It's like a weird stacking order. Let's pull up old malloc again. The trace is nice. Like, it feels like I have a slightly less bad set of tools for debugging this now. Tuco, what was that noise? Kitty. Oh, interesting. Lucas is elaborating on the tablet question. They say they want to try replacing the usual gimbals of a radio controller with a drawing tablet for racing drone controlling. That'd be interesting, yeah. And that makes sense too, because like I mean, I have never done like a racing drone, but I used to fly some like basic quadcopters, and so I'm used to the like two joysticks with the fingertips. So that could be pretty interesting, like replacing the two joysticks with like two pens. Yeah. That might be neat. The easiest way to prototype something like that would probably be to use a Raspberry Pi or maybe some kind of microcontroller that has good USB support built in, and then just connect unmodified tablets as USB human interface devices. That's like usually the easiest way to do it. Like, sometimes you can get lower level signals from these tablets, but they tend to be pretty integrated devices, and accessing the standard human input protocol that they spit out is almost always the most sensible way of accessing them. But if you wanted to try making like your own pen that works with an existing tablet, that might be kind of cool for like a joystick situation. And depending on the tablet, those can be really simple. Like the Wacom tablet that I was playing with on those videos, the full-on pen with the buttons and everything can be kind of complicated because you need to store the energy that you're getting from the tablet, and then there's like a sequence of bits that you have to send back to indicate the button status. But just indicating position is very simple, since it's just looking for like where on the surface of the tablet does it find some like inductive capacitive resonance. So all you need is the inductor and the capacitor. They have to be tuned, but if you can wind a coil and adjust the coil to match a capacitor you already have, or if you can use an existing coil and a variable capacitor, you can just find the resonance frequency and make something that will work as a pen. And then the other tablets I looked at by Huion, they use an active pen rather than a passive pen. So in their case, the pen is like a little radio transmitter transmitting on a fixed frequency. And actually, the frequency is a range of frequencies, and it changes depending on the pen pressure, so that's how it modulates the signal in there. Oh, Tuco. That's really cute, Tuco. Gosh. Oh, I guess by unmodified tablet, I just mean like a tablet, like a regular tablet, like that you haven't torn apart and made changes to. So like, just like a regular tablet. Yeah, I think the main thing that you would need to do is to find like a USB platform that you like. So maybe the Raspberry Pi, or maybe like some kind of Arduino with a USB host library. And if you find something that has library support for talking to USB input devices, but then there's also some way that you could glue it to your drone setup. So like I don't know what kind of like racing drone input setup you've got, but like if it's something, if it's like an Arducopter thing with like an open source radio, then maybe you could modify a transmitter to work with that, or maybe if it's like an off the shelf radio, you can find some way to interface with it. Oh, excuse me. Hey, Tuco. I don't think I have anything serious. I think this is just my usual seasonal sneeziness. Oh, interesting. If you want to try this on a simulator on a PC, then yeah, you might be able to just use some kind of like input remapping program on the computer. 'Cause that could be a totally software thing. You wouldn't have to fuss with the hardware if you don't want to. If you wanted to make it a hardware thing, you could probably find a device that has both USB device support and USB host support, so that it can like talk to USB devices while pretending to be a USB device. And then you could have it pretend to be a USB joystick while talking to two, or pretend to be two USB joysticks while talking to two USB tablets, something like that. But I bet there are just like input device mapper programs, especially like for Windows, that would do this. Like I think I've seen some powerful stuff that the gamer folks are all using these days. But I'm not really into that community, so I don't know. Oh, hey Alexis. Yes, this is Catstream. I've been like hacking on Rust, kind of making some progress on the sandbox project, but right now Tuco is stealing the show. Tuco really likes attention. Yeah, if you want to make like a hardware-based input device translator, I can imagine a bunch of different ways to do it. From like you could have a microcontroller with some kind of pretty general purpose USB interface on it, multiple general purpose USB interfaces. Um, Actually, I know there was a project that Kate Temkin, who used to hang out here sometimes, she was working on, that does um, like a USB emulation on the device side and the host side simultaneously, and you can write firmware that kind of interposes between those layers. So you could use something like that. I could also imagine doing something kind of at a lower level, even like taking an existing joystick and taking it apart and replacing the potentiometer. But like, I don't imagine that would be the easiest way to do it. But like, everybody's got different sets of tools and different sets of experience. So like, for some people, that probably is completely the easiest way to do it. Ears. Tuco has such good ears. He seems to like the ear massages, and I think a while ago, one of the vets I took Tuco to mentioned that like his particular kind of ears are extra prone to getting like wax buildups and stuff, so it is helpful to massage them. I think we both like that at this point. Oh hey, going down. Oops. Yeah, so Lucas, if you wanted to connect a tablet to the microcontroller, you could use a USB interface like I was suggesting, but if you did want to bypass that for whatever reason, you'd probably have to effectively take over the same control functions that the microcontroller in the tablet would be doing normally. Um, so you might need a microcontroller that has, a handful of digital outputs and maybe a couple of analog inputs, and you'd have to replicate at least some of the algorithm that the tablet microcontroller uses, which would depend on the specific kind of tablet, but generally it's sweeping across the surface by using some multiplexers to select one of several coils, and they're usually like long, skinny, rectangular coils. So there'll be a row of them down the front side of the board and a bunch of columns of them down the back side of the board, or vice versa. And you can select a couple of those and sample like which ones have the highest signal strength and use that to figure out where the pen is pretty accurately. But they do get a little fancy about that, like at least the Wacom tablet I was looking at, and I think the Huion tablet, the actual analog scanning takes some time, and so they optimize the refresh rate of the tablet by only scanning the coils that are near where it last saw the pen. And if it doesn't know where the pen is, it actually has to use a slower scanning mode that scans the entire tablet until it does find it. So there's kind of a refresh rate trade-off there. But that would be a little tricky, partly because you would need to be very particular about the analog design also. Like a lot of those signals are very sensitive, and so you need to be sure that you're not accidentally like coupling noise into the sensitive amplifier. And you'd also maybe need to make sure that the signals that you are intentionally transmitting out of the coils when you're trying to power up the pen mostly stay only where they're supposed to be. Like if you have wires flying everywhere, then those can act as additional transmitter coils. Oh, I think I'm allergic to Tuco. Excuse me. There's a question about whether I like Rust or Go more. I definitely like Rust more, but I've had more occasion to use it. I've had maybe a couple of projects where it seemed like Go would be a pretty good choice, but I've always decided it would be more fun to use Rust instead. And, a lot of the stuff I like to work on requires like a lower level control over the runtime environment than Go would usually give you. Oh, that's right. I was going to check on this offset, the 3A8. It's pretty much in the middle of that array. Seems fine. Okay, if this is the first malloc, where are these pointers actually coming from? Like, we should be able to see a call to expand heap. Gosh, it might be handy to actually start annotating this log a little bit. Will it just crash Emacs if I open this? File is large. Yes? What does literally mean? A large file detected cutting some corners. That's interesting. That didn't take long to load, at least. I'm assuming that means it mapped this whole thing. It just says so long instead of having line numbers. Actually, no, what is this supposed to be? Oh, this is the major mode? Really? I don't usually see the status bar in its full glory because I'm usually running this from the terminal. Interesting. Anyway, I actually do want the end of this file mostly. Okay, I want to mark where malloc is on here. I guess we can start with bin chunk. CCF1E. That's actually not too bad for a 100 megabyte text file. All right. So that should be the only malloc. Now, I wanted to mark down expand heap also. E5809. Okay, one instance of that. That's interesting. Okay, why is expand heap happening before malloc? Or sorry, this isn't actually malloc, this is bin. That's my mistake. This is bin chunk. Let's actually get malloc. CD263. Okay. So then before this should be xmalloc and then echo main. Expand heap. I'm kind of curious if we can find the code in malloc that decides we need to expand the heap, like where it's reading the existing pointers, and maybe that will be illuminating. I just want another window? Right, it'd be nice to look at this loop. I would expect the first time through this bin map should be empty. But let's just walk through malloc here. Let's adjust size. It's probably not important, but I'm kind of curious. Mm-hmm. Oh, it'd actually be nice to know what the size is we're allocating. Should know that now. CD263. Oh gosh, what is the calling convention? I think RDI. Are we really only allocating 4 bytes? I mean, that should be based on the length of our arguments, and I think that was pretty small. Like I was just saying echo high or something like that. This should be the amount that we're expanding the heap by. Oh, really? Really? That could be a problem if that's right. Like, really? That comes from up here, CD3, 4C. I wonder if I'm corrupting the stack during my system calls somehow. because that would cause maybe this problem. It looks like up here I've got this amount that I'm expanding the heap by or something in RAX. CD34C. That looks reasonable. I don't know if it's right, but it could be right. But then we go down, and I think we're trying to load that same value, var40, according to the disassembler, at CD388. And in fact, RAX still has the old value in it, but we're trying to get it into DI, and that's just not even right. So is our stack pointer bad? Let's check that. So 388 versus 34C. Stack pointer is the same. Is our stack itself getting corrupted? I don't know. Let's try back. I should make sure that push I did earlier didn't break any of the unit tests. Seems fine. Lucky number. Oh. I was just skipping over the fact that this is an LEA instead of a move. So like, that isn't actually supposed to be giving me the same value. I didn't realize expand heap took a stack pointer though. Like, what's going on there? Let's just look closer at expand heap. Oh yeah, I've been trying to run various kinds of programs. I mean, I want this to support all the libcs, but right now I've been dealing with what seems to be a statically linked position-independent binary that uses muscle. I'm just trying to get that working first. So I think the regular expand heap is getting inlined. And then this one does actually take a pointer to in. That's weird. Okay, this is just the code having a weird API, not actually being broken. So could that be right? I mean, it seems like break is mostly being called correctly, but like where is the result going? I would actually like to just figure out if I can find that bad pointer value and where it's coming from. Like back to plan A.5. Right, CBFDF. Where's that actually coming from? Right, so plus 18 is the offset of the previous pointer. R12 should be the actual memory like chunk. And I don't think that's in like a central place. I think this is a header on the actual memory block. So could we find this number maybe? Oops. No. So like, first of all, where even is this? 101 C7 BO30 is in the heap. It's that same offset. And like if this is our first malloc, why are we dealing with free list pointers in the heap already? These start pretty early. No, I guess this is wrapping. (1091). This is the first instance of it. CD240. So that's DI plus SI. I don't extremely care what this is doing. I think this is just padding the beginning of the memory block to handle the header and the necessary alignment. Is this, like, there's a loop in here, right? Is this just a previous iteration from the same malloc? Or is that not a loop? It's a little loop. But that's just a mutex. These are looping. That's weird. Alright, so that's after expand heap, but before bin chunk. Like, who's supposed to be initializing those pointers? Can we verify this is happening? I think that's size align. I think that's C in use. CD3EA. Oh, it'd probably be useful to know what expand heap returned. That looks right. And what is the end it was comparing it against? CD3B, or CD3DB. And RAX, RBP, and 0. Cool. So, I mean, we expect that to be initialized to 0 because it's in the BSS segment. It kind of seems like we're not ever explicitly initializing that. We're just leaving it zeroed, which should be fine. Look closer at bin chunk, maybe. So this double underscore bin chunk is the larger wrapper function, but I'm really just interested in this small piece. Don't care about Realloc. Is this all the unlock? recalls to bin index. Is the compiler removing some of those? Where are these? alloc rev and alloc forward. Is this the same code? Gosh, well maybe I've been fussing with this, like, in this kind of unstructured way too much, and I should just try recompiling this from source with more debugging. Because this doesn't seem to extremely match the code that I've got. It kind of does, but like I'm concerned about these bin index calls. It does not look like the compiler could merge these at all, but I only see one in the disassembly. And then the alloc forward and alloc reverse, like where does that even come from? So, oh, maybe I try to compile this more. This kind of started with like trying to do, sorry about the buzzing. This kind of started with trying to do, I mean, I was trying to just run off-the-shelf images and then debug them, right? But then I figured it would be useful to have BusyBox with symbols, so I went through the process to compile that, but it uses like a existing binary of muscle. Oh, so maybe we, excuse me, maybe we dig a little deeper. Okay, so these are just adding the finished tar file. So this is what I already tried. Like I've got an image that's built from the script already. Oh gosh, I've never tried compiling muscle. Maybe we should do that next. I guess we could start with Alpine and then just try to recompile whatever version it's already got. Be nice to know how the build process for that actually works so that I can run the same scripts. Really? I don't want to make an Alpine package. I want to make Alpine. How do I compile you? I don't think this is what I want. I don't understand why folks are so worried about the size of the base image, given that you only need one copy of it on the server. Does aport have the libc in it? these patches? Hmm. I was thinking it could cause some of these symptoms if we had a thread local storage problem, but then I didn't really see any thread local storage in the code that we're breaking. This elf aux header stuff is totally a thing that could be broken though. Like I'm filling this all out and I'm sure I'm doing something wrong. That's interesting. Which variables am I actually giving it? I am giving it AT base and P header, and they're both relocated. This is sort of assuming that the program header is mapped at address 0 before relocation. Maybe it's worth trying to find this in our disassembly. Default stack size. Init libc. Maybe it's worth stepping through this a little bit. This is reading the elf aux vector stuff too, and that's kind of suspicious that I'm not hitting this path. I was expecting that we'd want to save the hardware cap and whatever else is going on here. CPDD8. I think this points to the beginning of the elf auxiliary vector table. DFO. That seems plausible. In fact, it should be right after a pointer to the last environment variable. Which I think is path. So it should be right after something like that, 956 FOF 51. Or 7. Yeah, 57, sorry. Okay, so that's the last environment variable. Or is it F40? Oh, maybe those are in opposite order. Okay, yeah. This is at a lower address, but that's actually the last environment variable. The BusyBox version. Okay, so that's the environment variables. That's the null terminator at the end of the environment variables, and these are the elf auxiliary vectors. So yes, that pointer's correct, df0. We could check to see if these values make sense. Yeah, they're right here. These are the keys in this little key value list we have. So, and this is all hex. So 21 is actually 33. Sysinfo e-header. So this should be the beginning of the VDSO page. Which, I don't have the maps table in front of me, but that seems like it could be right. Like it's above the stack, but not by that much. And it's page aligned. So that's probably right. This is AT hardware cap. So, and I don't know if that's exactly right, but it looks roughly right. That's one of the CPU ID words. So I think that should be going into here. But maybe not. So like we've established that this doesn't quite match the actual source code I've got, but maybe we can find a close match in the source code. Oh. is very much the kind of thing that I would break by having a bug in my elf loader. Oh, that's weird. Huh. So they're just like unpacking the key value list into a flat array of the values that are below this aux count. Oh, old C code. It doesn't seem like we should be able to skip that. Yeah, so that's the unpacking loop, and then we should always end up here at CBDF5. Gosh, I'm so used to the Vim emulation mode now that when I accidentally turn it off and go back into regular Emacs mode, it's super weird. And then, like, I don't actually know the key combination to turn it on and off, so I often feel kind of stuck once I get into that state. I should look that up. Okay, that looks right. Gosh, what is that? It's like something else that doesn't match the actual source code I've got. That's interesting. I forget what sysinfo is, but I don't think I actually have it. And it seems optional in this version of Muscle. Okay. Yeah, I guess this is how other architectures do the VDSO. On x86-64, it uses eHeader to point to the VDSO. So whatever, I don't think that matters. What is going on there? Oh, are we flushing standard I/O? That is weird. I forget exactly how syspol works. I don't think I need to look that up right now, though. Oh, is this testing to see whether we have valid standard I/O, and if not, reopening dev null onto those FDs? That's interesting. What is this dot secure? So I don't know, I'm kind of suspicious of this thread local storage. Also, what is SSP? I assume this is like a stack protection token, using this random buffer that we've supplied it. Maybe I can check some of these other values. Right, I don't know why this would be checking sysinfo, unless it means sysinfo eheader. We jump right over that. Maybe we could check this program name. Looks like we jump over all that too. Okay, that should be the random data from the stack. Let's check out init TLS. What is this actually doing? And this is the code that was being patched in that Alpine build script. So like I'm not modifying the elf header at all. So like whatever the load instructions have mapped in, that's what it's getting, which I think is right. Could we check whether this dynamic base is correct? What is that value? Oh. That's probably coming from the linker script. That's probably the compile time value or the compile time address of that, and we're probably just using this to calculate an offset. Does this mean the base is different depending on what order these are in? Do we always have a PT program header pointing to the program header? I also have not been paying attention to this GNU stack header. Doesn't seem to be used for much right here. So yeah, I don't know what this PTP header is actually for. But we should be able to calculate a base from this. So maybe I can see if that's working. Okay, that's the zero terminator at the end of the auxiliary vector list. That's the end. Here's the loop around the auxiliary vectors. Here we're comparing the different, or sorry, this isn't looping over auxiliary vectors. This is looping over program headers. Right? Yeah, we're getting the program header address out of the auxiliary vectors, but this is looping over program headers. So what is PT dynamic? Two. Yeah, okay, so that's not a null terminator, that's the counter. Yeah, that's decrementing there, and that's adding. So RIX is the p header pointer. Two. And dynamic. So this should be the compile time address of the dynamic section. 11CFAO. It's in there. That might be right. I don't know if it's actually right, though. Well, let's try to find that in the trace. E3CD2. Oops. CE40. Oops. That's right. Cool. Yeah, that didn't quite match what the disassembler had calculated here, but actually that might just be the, what is this? Oh, is this just like a self-referential pointer inside the dynamic table? Oh, cool. Yeah, okay, these addresses do agree. It's just I was off by one level of indirection. So 11CE40. 11CE40. So we should end up at this subtraction. E3CE1. And RCX. Yes, and that calculates the right offset. Are we not storing that offset anywhere? I guess we just keep it in RCX until we're done with this loop. So RCX right here is the load offset. Where does that go? There it is. And when we're relocating something else here, E3, D33. E3, D33, none of that? Huh. Why aren't we getting there? RDX? DX is null right there. What is that about? We're skipping whatever this block is where we're actually using the offset and calculating something. Ah. Maybe we're just not doing any TLS right now. Okay, well, so no red flags there at least. It looks like everything that it's trying to do here seems to be working. But yeah, we don't actually have a TLS segment here. But despite it not using that, it's at least calculating the address correctly. See all these relocations? I don't know who's actually supposed to process these normally. Anyway, maybe it's time to go back to trying to compile muscle. I don't know if it's worth trying to use this build script or whether to just do it manually. Like, it seems silly to do anything manually with Docker when you could write a script to do it. Oh, hey, Tuco. Sorry, I'm a little behind on the chat. Tuco. Yeah, mostly I've been disassembling stuff because I've been crashing binaries that I don't totally have source code for. So it's like, do I keep doing that, or do I build a test setup that I have a bit more control over? And I think it's maybe time to do the latter. Yeah, I mean, I don't even have to use muscle. Like, I could go debug the uclibc or glibc versions of all this. The glibc version is dynamic, so I would need to get the elf interpreter loading, but I don't think that's a huge amount of work right now. So I could just try to get dynamic libraries working, but that's not going to make the debugging any simpler. There's probably some documentation for this. Yeah, we could just try this and see what works. I think I just want to mount a volume. Oops. This feels like it wants a slightly less ephemeral environment. Cool warning. Is that gone? Oh, here it is. Moved to GitLab. Nice. Yeah, let's just do it this way. Space. My home directory is much bigger than my root directory on this machine anyway. Oh. Gosh, the stream's getting a little long, huh? It'd be cool to have some cat company, but Tuco's been gone for a minute. Oh, there he is. You coming back, little guy? Do you want to look out the window? Oh. Hey. Yeah, you just trying to open all the doors? Let's put that there in case he comes back. Or are you just gonna stay there for a while? Yeah, I thought so. No? Focus. Tuco, there's some coldness coming out there. Gosh, this aports repo is big. Hello! What is going on with privileged Docker? I got a random question from JSOC Moss on YouTube chat. They're asking how I learned the reverse engineering and stuff. Mostly just I keep trying to take things apart and I don't give up extremely easily. I've had some opportunities to do reverse engineering, like at my job, but it's never been like my main job really. I mean, I guess it was for that brief period I was working at Sanrio, but like they weren't teaching me how to do it. It was just a thing that they were paying me for a while. Yeah, I think it mostly just comes from spending a lot of time doing things that involve taking stuff apart and trying to debug them. You know, I don't feel like it's something that's especially like specialized. It's mostly just like an amount of experience that you have staring at stuff and learning what the patterns are and how to, you know, how to figure out which part to look at next. I'm trying to run this Dockerized Alpine builder thing to build my own muscle tree. I don't know if it's going to give me all the build outputs I want, though. Like, this might be too automated. Tuca really likes that view or the fresh air or something. There's not much of a view. Maybe there would be more of a view if I turned on the outside light. Is that better, Tuco? Ah, did we build? I think we built. So where did the outputs go? Etsy. Really? Yeah, no. Why would I have that in Etsy? This is just starting with an existing binary blob of Alpine. and not doing a huge amount of extra work. Did it even save the results? That was an unkind place to put that directory. Well, I've got debug package and a dev package. I don't know how useful it is, but let's try building another. Oh, Tuku's over here again. Brr. Oh yeah, Ada says maybe the light will attract bugs for him. It's definitely done that in the past. Yeah, sometimes a year we've got these giant beetles. I don't know if it's going to find the packages that I build previously using this same setup. Yeah, I mean this is building against dependencies from the build image, not the ones that I just compiled. I don't know about this script. Eric is asking me to recall a succinct definition for AI. Something like algorithms and classification. The one that immediately springs to mind is the definition of AI as algorithms that don't work that one of my previous professors gave. He was specifically trying to distinguish AI from like the broader study of algorithms in computer science. Like, I mean, I feel like nowadays in popular culture the word algorithm is extremely fuzzy, but like the definition of algorithm that I'm used to from school is like a sequence of steps that you can prove always has certain properties. Like it always causes the output to transform in a certain way, or it always maintains certain invariants. And that he thought AI was kind of distinct from that realm because in AI, you have these algorithms that often work, but you have no way of proving that they work, and they often don't work that well. And it's more of like a probabilistic result, or it's something where you're trying to like in aggregate achieve results that are better than other methods. But like each individual result is something that you can't really prove is correct because it like relies on these sort of fuzzy parameters, or relies on assumptions, or relies on something that you can't actually turn into a concrete algorithm, because otherwise it wouldn't be AI, it would just be an algorithm. But fundamentally, I think a lot of the things that people call AI nowadays are statistical models that take a large pile of data and kind of help people forget where that data came from, and then surprise people with some results that they didn't realize were hidden inside that data all along. So this built a bunch of things. I don't know if that was actually useful. Like the thing I actually want is like a stripped binary and a non-stripped binary and like the exact source tree. So I could potentially run that again, but see if I can get that Docker a build thing to not throw away the build tree. Oh, is that cached? Interesting. Let's not have that be cached. That's annoying. All right. Christian's wondering what my shell is, if it's fish or some version of bash. I think my shell is just bash, but I don't know what shell Alpine is using inside of its image. Bash. So right now I'm trying to compile some of these things that have been crashing so that I can get maybe some better debug info. I did already compile my own busybox, but the crash is from somewhere deep inside of the libc. And so I don't really mind debugging it from the disassembly, but it's kind of annoying that the disassembly I have doesn't even actually match the source I have, and there are various ways around that, but the easiest thing to do might be to just recompile it with some fresh source, so that's what I'm trying to do here. If I could get a single busybox binary that is statically linked against a version of musl that I have source code for, that would be basically ideal. Okay. I don't think it actually saved anything to this image, though. Yeah, I mean, I think this is a stateless image that's just immediately installing all the stuff that we just built from a mounted volume. That's not actually what I wanted. I don't know why this isn't giving me a new image. Right, like this is the base image that it downloaded, but I thought it would give me like an ephemeral image for each container that I instantiate with it. Maybe I should just switch approaches and use something other than that script, like just make my own Docker. What's that called? Cool, I've got a build. Let's just try a build -r here. Oh yeah. This isn't actually root, come on. Yeah. Okay. I don't know where Tuco is. Yeah, happy to try to answer questions even if I can't find the exact answer folks are looking for. Gosh, I'm probably gonna have to take a break at some point because this is just digging into my head too much. Needs like a little foam pad on the other side. I don't know why it's got a foam pad on one ear cup but not the other ear cup. Oh! It does have a foam pad on both sides, but it was like squeezing my glasses into my face, so it felt worse than it usually should. Interesting. Gosh, I've had these glasses for way too long, and all of the padding on their arms is worn off. I could talk a little bit about the context while this is building. I mentioned some of this earlier, but this is all for a little sandbox that I've been trying to build in Rust. And the idea here is for it to be a very simple and easy to deploy way to run stuff like media transcodes in a lower privilege environment than you otherwise would be. So part of it is, like another layer of security, but part of it is actually just for convenience so that you can run these like versioned FFmpeg containers in various deployment environments, including unprivileged Docker containers. Okay. So do we actually have a build directory somewhere that we can get to it? Oh, why did it purge all this stuff? Keep the tempters. Is this gonna leave me a nice tasty static binary? This might actually be easier to do without APK. I don't know if this is going to give me a libc that I have source for now. Oh, that's an interesting idea, putting the headphones on differently if they're really tight. Yeah. Oh, that's interesting. Yeah, putting that on the ear. It's like I wouldn't want to always wear it like that, but it's kind of a nice relief from the other way. And my glasses are kind of crooked, but I don't extremely care. Hmm. Okay. Ooh, that's nicer. Ah, is that an unstripped static busy box? This looks similar to what we had before, so it's a Dyn binary, so it's position independent code, but it has no interpreter, and it should be statically linked with everything that it needs. Presumably including whatever linker is handling those relocations. Just curious if there are any functions with rel in them. Maybe I can just browse the muscle source code and get some idea of how it actually is supposed to do the relocations. Let's just do that too. Oh, what are those called? Is there no relocator in here either? Does muscle not include its own dynamic linker? Sure it does. It's right there, LDSO. It's awfully little. How do relocks? Oh, do we have symbols for that? Do relocks? That doesn't seem right either. we have DL start? What is that? Huh. I still don't really know how relocations are supposed to happen in this binary. You know, I guess I could run it under GDB and set hardware breakpoints and try to find the relocations. This is very similar to that base calculation we were seeing earlier, but I think this is actually a different instance of it. This is the actual dynamic binary. And so it starts out with a p header and then interp. Load, load, load. Is that offset right? Yeah, I guess that is not actually the elf header, that's actually the array of program headers. Interesting. What is that? Combined relocations? Only someone who doesn't actually know how relocation works would state with such confidence that they know how relocation works. Yeah, what is rel RO? Go away. Go away. Whoa. What info? Right? How are we doing this? Okay, data.rel.ro is right next to dynamic here. So presumably at some point we call mprotect to change this section to partially read-only. There's the dynamic linker. Maybe I am missing, like, I don't even know how this gets invoked in a static PIE binary, so maybe that's part of what I'm missing. I still kind of can't believe that it looks like the whole dynamic linker is just two source files here. Kind of long source files. Oh gosh. Oh, there's rel ro. How did I miss that one? I'm having terminal problems now. I don't know why I do a search and then my cursor disappears. Yeah, there's the other one. What's up with that? I assume that's a terminal emulation problem. Anyway, relock all certainly seems to be a thing that I want to call. How does that get called? This has got to be a terminal problem with Docker. Ah, DLS2, I've seen that. So there's DLS2. Can we verify where the actual entry point is? 05A, which is underbar start. Let's call start C. It's interesting that I was seeing stage 2 of the dynamic linker, but I don't know if I've seen stage 1 yet. I mean, this part might be different for normal dynamic objects versus for position-independent code. Do we see calls to DLS2 elsewhere? Maybe this is RCRT1? Let's check that out. No. No. So we're looking for a call to DLS2 somewhere that might get inlined into start C. Where is actually start C defined? Is rcrt the C runtime startup file for relocatable binaries? Interesting. That's important. So, gosh. Yeah, this has got to be the C startup for relocatable binaries, and in this case, start C is actually DL start C, which should have a call to DLS2. So yeah, my hunch earlier was that there was a tiny version of the dynamic linker that was linked into this program, and it does seem to be that's what's going on. So deal start C actually turns into start C, and that matches what we're seeing in the disassembler. So is this doing the first stage then? I guess this is actually the first stage relocation. I don't see that. Oh. No, this is it. So this is only handling these particular kinds of relative relocations, and then everything else happens in the second stage. This should be the two loops right above DLS2 are the relocation loops. So DLS2, one loop, two loops. So let's look at the instruction trace starting at 8145. Nothing. Do we have the very beginning here? 8070. That's on the stack. Oh, this is the editor that I switched into the mode I didn't actually want. Oh, what is this loop? edit it. It's the loop that's counting arguments. That's zeroing the aux array. And is this the one that's storing to the aux array? Yes. And that's zeroing the dyn vector array. Is this going to be something I was supposed to fill in? I should make sure that's actually happening. So this should be copying the key value pieces out of that PT dynamic. Not this though. I don't think this block is included. This FD pick is not common. I don't know if I feel like decoding all those, but it looks like we're at least getting into that loop. So we did look at a different version of this base address calculation, but let's make sure this one works too. Base equals aux at base. So that was the loop zeroing dyn. That's the loop storing the dyn values. That might be base 80fe. Yes, that's the correct base, and it didn't have to calculate it. It just got the one that we put in the aux vectors. This AT base came from the elf loader that I wrote, so it is getting that correctly. So we're skipping that, because this is not a MIPS binary. But then we should have 2 loops left. So I should comment some of this stuff. Where did that comment go? Oh, there it is. Okay, so we're jumping over that, down here. 2 loops left. 1 loop, 2 loops, DLS. So these are both relocation loops, just like we were thinking before. Let's look at the trace right here, 8145. So it looks like we skipped this first loop entirely. We go right from 8151 to 8172. A191. 8191 to 8193. So we do not skip the second loop. So that's rel versus rel A. I forget what those are actually. So this is the dyne section. Okay, yeah, so we have no rel, but we do have rel A. We have 208 rel A relocations. Or sorry, that's the address of rel A. We have 24 rel A entries. Is that right, though? 31,000 bytes? What part of ELF do these actually come from? Oh, that's not the number of entries, that's the size of one entry. Okay, so there are a lot of relocations, as you'd expect for a reasonably sized program. Okay. Well, seems fine. So does it seem like the relocation loop is actually relocating? So this isn't using rela ent here, but that does match. That's 3 words which seems to be what it's doing here. That looks pretty straightforward. I kind of doubt that that's broken at this point, but let's check it out. All right. I guess that's the address, and then some kind of type information, and then the new value. Okay, so every one of these 81AD instructions is writing a relocation. DI is the base adjustment. SI is the unrelocated address it's writing to, which also looks right. And R9 should be the new value, which we just added DI to. That's cool. It's looking like this problem might not be relocation related at all. So this seems to be all correct. I wonder if it would be illuminating to actually try to get dynamic linking working. It feels like it wouldn't be that much work to get dynamic linking going, and maybe just having more of a variety of test programs to run against this, I would have an easier time finding this particular bug. Since odds are it's probably something really fundamental that I'm only hitting on some programs for some reason. You know, it could be a buffer overflow of some sort, it could be a memory mapping issue, but I don't really know at this point. It still seems kind of likely it's related to thread local storage, but I don't even know if this program has any thread local storage. Like, it seems like that's the kind of thing you would have inside of a malloc implementation, but I haven't seen any actual evidence of that yet. Oh man, I might have to wrap this up. This has been almost 7 hours so far, and I think I need to get a bite to eat and give my skull a rest from these squishy headphones, or squishy headset. Gosh, I feel like we didn't really accomplish much actual debugging, but I feel like I've ruled out a couple things. Like, I think the relocations are working right, and before this stream, I had no idea if the relocations were working, so that's kind of cool. And I did make some changes to make debugging a little bit easier. Let's make sure those are actually checked in. Oh yeah, I was gonna check the test suite. Oh yeah, I already checked this earlier. That's fine. We have not had any changes since 420. Well, I think that's an alright stopping point for this particular session. I'm gonna keep trying to debug this probably, but I think I need a break from the streaming. I need to get some food. So just for a little bit of a step back, so this is all part of what's trying to be a kind of decentralized video server project. But the piece of it I'm working on right now is a lightweight sandbox that's used for video transcoding. So the idea is that this is a Rust library that will be able to run things like FFmpeg in a lightweight, unprivileged sandbox with minimal fuss and minimal dependencies. But it's not there yet. Right now it's more like 10,000 lines of Rust that doesn't really do much except produce weird crashes and lots of logging output. But we do have lots of logging output, and this is kind of nice. This is like a full trace of the CPU registers after every instruction, so it's extremely verbose, but it's kind of helpful at this point in the debugging. So yeah, if anybody has questions or suggestions or comments for future streams, be sure to send them my way. I'm usually paying attention to Twitter, and when my email is not terrible, I try to pay attention to my email. And a special thanks to everyone who supports me on Patreon. I always try to pay attention to Patreon, and I'm really grateful for the folks who support me on a monthly basis so that I can keep doing this and paying my electric bill and paying for my health insurance. So thank you. I will keep trying to make things that are useful for folks and document them with video. So yeah, let me know if you have suggestions for how to prioritize that, but otherwise I'll just keep trying to do what I'm doing. And streaming when Tuco's around. Sorry he took off a little early today. Anyway, thanks a lot everyone. Happy hacking, and I'll see you next time.